Hey everyone, welcome back. In this tutorial, we'll walk through how to use ChromaDB as your vector database for all your retrieval augmented generation tasks. But before you do, you need to install Chroma. I have Chroma installed, so I'm going to just run this. This should, you know, and then we want to also load in all our libraries that we will require. So we need Chroma and embedding functions, and then all the libraries that we require. We also need some helper functions from LangChain. So if you don't have LangChain, you can install it from here like this. So it will install LangChain as well. Like I said, I already have LangChain installed with me. So yes. So to get started, what you need to do is create a persistent client. Now, the reason that we are creating a persistent client is that you can use this client anytime that you want. If you don't save it on disk, then whatever task that you do will go away. So that's why we create the persistent client, and you need to provide the path. So I'm just installing, like saving it in the current directory. And in settings, if you want to allow reset of your client, then you need to add this setting, which is ChromaDB config setting, allow reset is equals true. This will allow you to reset the client, otherwise you'll not be allowed to reset the client. And then we'll define an embedding function, right? Now, why we require the embedding function is that whenever you create a collection, uh, well, actually, while creating the collection, you don't have to define the embedding function. But whenever you do get collection or whenever you want to add some documents to your collection, you need to pass in an embedding function. If you don't use the embedding function, then I think Chroma uses this embedding function as the default, as far as I remember. Uh, yes, so this is the sentence transformer that it uses by default. And the embedding function that you use is really important, right? So let's say your embedding function is all mini lm L6B2, which is the default one. And then the max sequence length that it can handle is 256. So let's say your documents is larger than 256, then what it will do, it will truncate that document and then embed it in the collection. But if you want to pass in larger documents, you need to use embedding functions that can handle those documents. So that's why the embedding function that you use is very critical. And also remember to pass the same embedding function in the collection when you have added documents and when you're retrieving the collection. Because if you don't do so, then you have different embedding functions doing different tasks. One embedding function that was used to embed documents and the other embedding function that you're trying to query your collection. Collection is like a database. So if you use BigQuery, there's project and there's like database, and then under database there are like tables, right? So your project is like the client, your collection is like the database, and the documents are like the tables if you are coming from BigQuery or like SQL background. So we are going to use the OpenAI embedding function, text embedding 3 small. I don't know what its max sequence length is exactly, since it's not open source, the information is not that easy to find, but I know it's larger than 256 and it's pretty cheap. So that's why we are going to use this embedding function, but you're free to use any embedding function that you feel fit. There are plenty of embedding functions. You can use Olama embeddings, you can use sentence transformers. They are all very good and they are free, like open source. So let's define our embedding function. And now we're going to create our collection. Like I explained before, collection is like your database. So we're going to create a collection and we're going to call it research, you know. And while creating the collection, I'm only going to pass the embedding function. But like I said, you don't need to pass it while creating, but you do need to pass it when you're adding documents if they are not already in embedding format, which we usually don't. We're going to pass documents as text, and we're going to let Chroma handle the embedding, creating them as embeddings. So let's create our collection. Then we're going to load in some helper function. We're going to load in the recursive character text splitter from LangChain. And we also going to load document loaders like PDF loader from LangChain, right? So these are the helper functions. So we don't need to worry about, splitting the text or, how to load PDF. And I also have a PDF here that I'm going to pass. Now, the PDF loader will load in the PDF, and we want to split it into chunks, and we want to split it into chunk size of 2000 with a chunk overlap of 50 with these separators. What this huge, so you can learn more about it. You can refer to the link in the description where I have the blog post which goes into detail where it is, and it also cites the sources where you can go to exactly know about the PyPDF loader and the recursive text splitter. But these are the simple helper functions. The objective of this tutorial is not to deep dive into them, but do leave a comment if you want to know about it. Chunk size is roughly how many tokens you want in each chunk, and chunk overlap is how many chunks are overlapped between two different documents. So you can keep it as 0, I'm keeping it as 50. So we're going to initialize both of them, and we are going to load in our documents. So we got a PDF loader, load and split, and you can pass the text splitter, and text splitter is this text splitter which is going to split it on, line break, dot, space, and empty characters. And we have roughly 48 documents to add. Now comes the part of adding the documents to your database. So to add, you just call the collection.add, and you're gonna pass the documents that is. Now, if we look at the documents, then you will see that the document has document, page content, and then page number, right? And then there's some metadata here, right? And then again, there's like some, page metadata, and then the page number, right? So to add the documents, is the raw text that you want to add, and in the IDs, I'm just going to pass the ID, and why do you need to add IDs? IDs is like the table names, right? So while adding the documents, you need to remember to add IDs to it, and it is often in the string format. So I'm going to just type PDF chunk number in the range of documents. I could also use this, right? This as the ID, which is like which page number of this it is. So that is also a nifty thing to use when you are using PDF loader, because it will add the metadata for you, which is what is the source and what was the page number, right? So I can use this metadata to add some metadata also here. But for metadata, I'm just going to use the file name, which is research paper, and the timestamp as to when this document was added in the collection. So let's run this. And yeah, this was pretty fast. Now you can, this is pretty much what you need to add documents to your vector database. But we know that adding is easy. What we need to do is query our vector database to find relevant information, right? So let's start with the query. So the first thing that you need to know about querying the collection is simple, collection.peek. So it's just like the name says, you can peek your database and you can pass how many top documents you want to see. Let's say you want to peek at the first documents. So if I add this, it returns the ID, PDF chunk 0, and then the embeddings, right? So, and then it also tells you the metadata which was there, so file name and timestamp when it was added, and what was there in the documents, right? And if I want to see, and so this returns a dictionary, so I can just go and then I can just go embeddings, and I can see the shape. All right. So it's not a numpy array, so I need to get this length of embedding. So it's 1536 embedding length, right? So you can peek n number of documents. The more documents you peek, it's gonna return it in the dictionary format. So if we peek 2 documents, you see here, and then like 2 PDF chunks, the embedding will be longer, and it's pretty fast, as you can see. And then there's all those documents, and yep. So also peek is only to check, it's cool, but you are never going to use peek in reality in your programs. What you need to know is how can I get the exact documents, right? What we need to know is how can I get the document uh, regarding a particular ID. So you can get that using collection.get. Now collection.get has two parts. You can get it. So if we look at the help, you know, and you will see you can get it based on the IDs, and you can get it on where, right? And there's also some where document, which I don't know much about. To be honest, I haven't used it, but I know you can use it using IDs and where. We'll just showcase both of them here. Uh, I'll add a follow-up to this video known as, the Chroma Vector Database Guide, which is in depth for advanced users, but for beginner, I think if you know how to use get with IDs and where, it's okay. So we remember we initialize some IDs when we were adding the documents to the collection, page content, the ID is PDF chunk 0. So if I want, I can get the IDs related to some chunk numbers. So PDF chunk 0 and PDF chunk 1. You see, it returns those IDs and it returns the metadata and the documents from the collection, right? Similarly, you can get the collection from where uses the metadata that you have added. So we remember we added the metadata as a research paper in the file. If you remember here, we added metadata, file name is research paper. So any metadata that you added, you can use it to query your documents. Here, all the IDs will be returned. So you see, all the documents are returned here. So this is finding the data in your, uh, vector database documents. Now what you need to know is how can I, we know how to add the data, but what if you want to upsert the data? What if you want to remove the data that is already there in a particular document and you want to replace it with something else? Probably you want to use the same collection, the data is now old that you have added before, you want to just, use the same document ID and you want to upsert it. So the way to do this is using collection.upsert. Again, you have to pass the IDs and the document that you want to embed. The embedding function, the collection already knows what embedding function to use, so you don't have to specify it. And if you see, once we do the upsert, now if I do collection.get using on the same ID, you see the document has changed. This is an example of upsertion. Earlier, you see when we got the text from the PDF paper, like PDF research paper that we are using before. But remember, upsert also works as an add. So if say I wanna upsert PDF chunk 9999, but does addition. So if it cannot find the ID, it will create it. So if you see, we only had 48 documents. So, the PDF chunk 999999 doesn't exist. But once I ran it, it still ran without an error. And if I get collection.get and I pass this ID, you see this is now a part of my collection. So how Upsert works is that if you don't have that document, if you don't have that ID, it will create it for you. So, like the document says, this is an example of upsertion but does deletion, right? There are also one thing that you can do, which is query your vector database. Now you can use this with, well, like the name says, collection.query. So how collection.query works is that it queries texts based on the text that you're providing. So let's say I want to query a text, and so query text takes two parts, query text. Now you can pass n number of text to it, and you can also specify how many closest matching documents you want to return. So let's say I want to return only one closest matching, and I only want to query one text, which is which document talks about upsertion. Now, let's say if I want to query two documents, it will return two document IDs, the document ID 0 and the document ID 999999. Let's see if it does that only. And as you can see, it does understand the context. It does find the closest similarity. which is PDF chunk 0 and PDF chunk 99999, and it returns also the documents. It's an example of absorption. This is an example of absorption, but additions. You can ask multiple questions at the same time. What is the title of the research paper? And you'll see it returns all of them in a single dictionary format with IDs of both the questions and then distances of both the questions and then the metadata and then both the documents. Like this is an example of absorption, addition, and it tries to find you know the title of the paper, but since we have already removed the document which contained the title of the paper, it doesn't find the correct document because it doesn't actually exist in the vector database. So that's a guide on how you can use document addition, document absorption, document querying your vector database and querying your vector database using questions. So this is particularly useful in retrieval augmented generation creation where you want to know which documents were passed as context. This will give you the context along with your prompt. So prompt plus context, and you can also control how many context vectors to pass. uh, this is also provided by LangChain, so you don't have to worry about writing this, but let's say you want to know exactly which documents are passed, which it's a bit fuzzy to get that in LangChain. You know how it is doing so. So now comes deletion. In databases and in SQL also, if you're managing any database, you need to delete documents as well. And you can delete so using collection.delete. Again, you can delete it using either IDs or you can pass the where, just like in get, you can delete it using the same. So I'm going to delete PDF chunk 0, and also, so now if I just pass collection.get, now also collection.get gives you the entire vector database, right? As you can see, there is no PDF chunk 1. So it's okay for the store example, but if for large vector databases, collection.get is not recommended to use. And you can also delete using where. Now if I do it here, you will see my entire collection documents are gone. You see, I get 1 second, it should be should delete everything. I don't know why. File name is okay, so the file name is so there was a typo. So now you see everything is gone except this particular ID which had no metadata, so it can't be deleted using this. Or you can delete the entire database using client.delete collection research. So you can just do this, and now if I try to if I try to get this collection, it will say it doesn't exist. Value error, collection resource does not exist because I just deleted it. Again, if you have created the client using the setting, yeah, allow reset is equals to true, you can reset the client, which will remove all its collections, right? So let's create a collection, client create collection, and let's call it random. Now if I try to get client client so you see, if I try to count the collections, it says there are 1 collections, but I can do client dot reset, and if I run this again, it should give me 0 because essentially the client has been reset, and resetting the client removes all data that is in the client. So all right, that is all that there is I have to talk about in this, guide to using Chroma vector database for your RAG applications. You can use it for RAG applications. You can use it to store documents in the form of vector embeddings. Uh, I will also create one of the advanced user guide of this particular concept that is already in the works. So stay tuned and do like and subscribe. All right, thanks for watching.